There is something deeply concerning about watching a second storm system move toward communities that are still recovering from last week. The same corridor, the same communities before they had time to fully recover, the same families who spent last week clearing debris, checking on neighbours, and trying to piece things back together now watching the skies darken again. And what makes this one stand out is that meteorologists are not calling this a continuation of last week. They are calling it a completely separate, independent weather event with its own energy, its own structure, and in several important ways, more intensity than the one that just came through. Two significant tornado outbreaks striking the same region in less than 2 weeks, each driven by its own system, is the kind of sequence that weather professionals take very seriously, and it is exactly what is unfolding right now. Let us go through this together, because what makes this second outbreak different from the first takes more than a headline to explain, and every part of it matters. We are going to cover what is happening in the atmosphere right now, why the ground itself has quietly become one of the biggest dangers in this event, where this storm is heading over the next day or two, and what the larger pattern may be telling us about why the same communities keep finding themselves in the crosshairs. Because here is the question that keeps surfacing the more you look at this outbreak. Why here again? Why the same states? Why the same communities that were already knocked back before they had time to get back on their feet? That question is going to run through everything we cover today, not because there is a tidy answer waiting at the end, but because sitting with that question honestly is exactly what helps you make sense of what you are watching unfold in real time. The week before, this one already delivered one of the more impactful severe weather sequences this part of the country has seen in recent memory. Homes were damaged. Communities were left with the kind of aftermath that does not resolve in days, it resolves in weeks, sometimes months. And before that cleanup is even close to finished, another storm system has organised and is now moving. If you watched our last video covering that first outbreak, you already know how serious it was. This is not a repeat of that story, it is a completely new one, and in several important ways, a more complex one. The Storm Prediction Centre has issued alerts for this event at a higher level than the previous outbreak carried for most of the affected areas. NOAA is tracking it. Fox Weather has dedicated coverage to it around the clock. This is not a watch and wait situation, it is already happening. What I want to do with this video is walk you through it carefully and clearly, not with alarm, not with exaggeration, with the kind of grounded attention that a serious weather event and the communities dealing with it actually deserves. Because when a storm hits people who are already down, the least we can do is pay honest attention to what is happening and why. If you have been following the weather situation in the central US this month, you already feel the weight of this second strike. And if this is the first you are hearing of it, you are in the right place, and everything you need to understand what is happening is right here in this video. Hit like and subscribe. It helps this information reach more people who need it. Drop a comment telling me where you're watching from, or if you have family in the path. That community of people sharing what they know genuinely matters right now. Let us start with what is confirmed. What we actually know, right now, about this second outbreak, because the confirmed facts are enough. You do not need anything added to them to understand why this event has the full attention of every major weather organisation in the country. The Storm Prediction Centre has issued an elevated severe weather risk for portions of this outbreak's path higher than the level that covered most of the affected areas during the previous week's outbreak. That distinction matters. It is not the highest level on their scale, but an elevated designation from the Storm Prediction Centre represents a real, meaningful assessment, the kind that reflects genuine atmospheric conditions and moves serious preparation from optional to necessary. The fact that this second system carries a higher alert level for portions of its track compared to the previous one is the first signal that professional forecasters are not treating this as more of the same situation with a different date on it. They are treating it as something that requires sharper, more careful attention. Here is what is structurally different about this outbreak compared to last week's. The earlier outbreak was driven by a single organised low-pressure system that tracked east across the Central Plains, pulling warm and cold air into conflict in the way that generates severe weather. That system was dangerous. It was serious. It left real damage behind. But it had a relatively defined core of energy, a somewhat predictable track, and a storm field that, while it covered a wide area, was organised around a single centre of atmospheric activity. Forecasters could draw a reasonably tight picture of where the worst conditions would develop and when. This outbreak is being driven by two separate low-pressure systems that are converging. They are not moving in parallel tracks that occasionally brush against each other. They are on paths that bring them into direct interaction across the central United States. When two storm systems converge rather than move independently, the atmospheric behavior between them becomes harder to model and harder to time. The energy between them does not simply add together in a clean, predictable way. It combines in a more turbulent, less organized fashion that expands the zone of potential severe weather activity and makes the forecast window less precise. Meteorologists from NOAA and the Storm Prediction Center have both noted this dual system dynamic as a defining feature of this outbreak, and it directly affects how communities in the path should think about the timing and location of the worst activity. The geographic footprint of this outbreak is also wider than last week's. The stretch of states under some level of active risk with this system extends further east than the previous outbreak's primary impact zone did. That is not a small distinction. It means communities that were not in the main path last week, places that watched the coverage and felt the particular mix of relief and concern that comes with narrowly avoiding something serious, are now directly in the projected track. The storm is not simply revisiting the same ground. It is also moving into new territory, pulling the active risk area further east and drawing in regions that have not been dealing with severe weather watches and warnings for the past week. Large hail is a confirmed and prominent part of this outbreak's threat picture, not as a background detail, but as a significant documented element of what this system is already producing. Hail at the size being reported with this event carries enough force to cause serious property damage, to be genuinely dangerous for anyone caught outside, and to arrive faster than people sometimes realize. It is not the threat that dominates the television coverage the way tornadoes do, but it is every bit as real and every bit as immediate for the communities in the path of the most energized portions of this storm. Fox Weather's team has been tracking this system actively throughout its development, and what they are emphasizing is consistent with what the Storm Prediction Center is focused on: the dual system interaction, and what it means for the eastern half of the outbreak's projected track. The portions of this storm that carry the most uncertainty right now are the portions furthest east, and those are precisely the portions that the storm is moving toward. The eastward push through Missouri into Illinois, pushing toward Indiana and Ohio, and the upper deep south is the active, developing edge of this story. It is the part that is still being determined in real time, as the two systems continue to interact and forecasters refine their picture of where the most intense activity will concentrate. Something worth acknowledging directly: communities that absorbed the brunt of the previous week's outbreak are not automatically protected from this one. Some of them remain within the elevated risk zone because the new system's track overlaps with the previous one across portions of the central corridor. The instinct to assume that a place that was just hit is somehow used up for the season, that lightning doesn't strike twice, so to speak, is a completely understandable human reaction to a genuinely difficult situation. It is also incorrect. Weather systems do not track historical impacts. They follow atmospheric conditions, and right now, the atmospheric conditions are supporting a second significant event across territory that is still in the middle of processing the first one. What is already confirmed for this outbreak includes active tornado reports, documented large hail, and damaging wind activity across portions of the southern plains. Those are not projections, they are ongoing as this system develops. The watches and warnings currently in effect across the affected states reflect real-time assessments by the people who watch the atmosphere most closely, and what they are seeing has earned this outbreak a higher level of concern and a wider geographic focus than the one that preceded it just days earlier. But the most alarming part of this outbreak has nothing to do with the tornadoes themselves, and that is coming up next. When people follow severe weather coverage, the conversation almost always focuses on what is happening in the air, the wind, the rotation, the storm cells producing the headlines and the camera footage. And all of that is real and all of it matters in this outbreak. But there is something else happening in this second strike that is not getting the attention it deserves in most of the coverage, and it is one of the key dangers forecasters are watching closely as this system moves through. It is not something you can see on radar. It is something that has been quietly building under the surface since last week. The ground is already full. That sounds almost too simple to be significant. But the implications are anything but simple. The previous outbreak did not just bring tornadoes and wind through the central corridor, it also delivered substantial rainfall across a wide portion of the region over the course of several days. That rain soaked into the soil. Normally the soil in this region has a meaningful capacity to absorb incoming moisture, hold it, and release it gradually back into waterways in the atmosphere. Right now, The soil across much of the affected corridor does not have that room. It is saturated, not damp, not holding a little more moisture than usual, genuinely full at or near maximum water content. And when rain falls on saturated ground, there is no absorption process to slow it down. The water moves immediately to the surface, runs downhill, collects in low areas, fills drainage systems, and raises water levels in rivers and streams that are already elevated from last week's rainfall. It does not matter how hard or soft the rain falls if the ground cannot take it in, all of it becomes surface water. All of it flows. Think of it like a glass filled right to the brim. Any extra water you pour in goes straight over the side. That is what the ground is doing right now. What that means in practical terms is that rainfall amounts this week that would be completely manageable under normal conditions. Moderate rain, the kind that might produce localized puddles and slightly elevated creeks on a typical spring day, become a flash flooding threat when they land on ground that is already at capacity. Rivers and streams that rose with last week's event have had only days to begin their recovery. In many locations, they have not come down significantly at all. So the rain associated with this second outbreak is not adding to a dry, receptive landscape. It is adding to an already stressed elevated waterways, full drainage systems and ground that will immediately redirect everything downward and into the nearest low point. This is the definition of what meteorologists call a compound weather event, a situation where one significant weather event creates the conditions that make the next one more dangerous than it would have been independently. The first outbreak set up the ground. The second outbreak is arriving into that setup. Two significant storm systems hitting the same region within days of each other is something that individual alerts, tornado watches, flood watches, wind advisories do not fully communicate on their own. Each alert addresses its specific threat accurately. What they do not collectively convey is the way those threats reinforce each other when they are operating simultaneously on already compromised ground. The second layer of hidden danger in this outbreak connects back to the dual system structure that we touched on when discussing what makes this event structurally different from last week's. And it is worth spending a moment on the practical implications of that structure, because it directly shapes how predictable this outbreak's behavior will be. When a single, well-organized low-pressure system moves through a region, forecasters work from a reasonably clear model of where the most intense storm activity will develop and when. The energy source is one system. The moisture inflow is relatively consistent. The timing of the outbreak's peak activity can be projected with meaningful confidence. Forecasters have spent decades building expertise around single-system severe weather events, and their tools and track records for those setups are genuinely impressive. Two interacting systems is a fundamentally different problem. When two low-pressure systems converge over the same region, the meteorological behavior in the zone between them, and in the zone where their energy fields overlap, becomes more turbulent and less responsive to clean predictive modelling. Storm cells in that convergent zone can develop more rapidly than the models anticipated. They can intensify with less warning time. They can produce significant activity in areas that were listed as moderate to risk on the morning outlook, and move to active warning status within hours. The forecast tools are handling more variables simultaneously, and every additional variable is an additional source of uncertainty about exactly where and when the worst moments of the outbreak will occur. That is not a criticism of the forecasting community, it is a description of a genuinely harder problem, and it is one of the reasons why communities on the outer edges of the risk area have less margin for error than they would in a simpler single-system event. The edge of the risk zone is not a hard boundary this time, it is a gradient, and the uncertainty within that gradient is meaningful. When you lay a saturated ground which turns moderate rain into a flooding threat on top of an unpredictable dual-system interaction that can produce intense activity in locations that were not considered central to the risk corridor, what you have is a situation where the danger is more widespread, more variable, and more capable of affecting communities outside the obvious bullseye than the first outbreak was. The Storm Prediction Center and NOAA are monitoring both of these elements actively and factoring them into the elevated alert posture for this event. And that unpredictability is exactly what makes the next part of this story so important to understand, because we have not yet talked about where this storm is actually going. And when you look at the states now directly in this system's eastward path, the picture of who needs to be paying attention changes significantly from last week. This storm did not stay in one place. What started in Texas and Oklahoma has been moving steadily northeast and east, and the states now in its path are different from the ones that were hit last week. That is the moment this outbreak is in right now. What began in the southern plains, in Texas, in Oklahoma, in the portion of the country that has built its entire weather culture around the reality of severe storm seasons, has been tracking steadily northeast and east. The storm is moving. The map of who is in the path is not the same map it was 24 hours ago. And for a growing number of communities and families watching this develop, more communities are now moving into the active risk zone as the storm tracks east. The initial, most energized activity in this outbreak developed across the Texas and Oklahoma corridor, a region that carries generations of experience with exactly this kind of weather. Those communities know how to read a sky, how to monitor a forecast, how to move quickly when the conditions require it. That experience and that cultural readiness matter enormously. But experience helps people respond quickly, but it does not reduce the physical threat that the storm brings. From that starting point, the system has been pushing northeast and east, pulling the active severe weather risk through Missouri and into Illinois. The southern Missouri corridor and the central and southern portions of Illinois have their own history, with significant tornado outbreaks, and the progression of this system into those states is consistent with how these large energy-rich weather systems typically move once they have organized and begun their eastward track. But the leading edge of this storm, the part that forecasters from NOAEA and the Storm Prediction Center are focused on most carefully right now, is the push further east into Indiana, Ohio, and down into the deep south, which in this system's case means Tennessee, Kentucky, Mississippi, and portions of Alabama and Georgia. Some of these states were on the outer edge of the previous week's outbreak. They had near misses. They watched the coverage, felt the weight of what was happening just to their west, and moved forward with a mixture of relief and awareness that they had been close to something serious. That relief does not transfer to this outbreak. The eastern track of this system means that the states which felt relatively if cautiously safe during the previous week's event are now directly in the projected path of this one. Not all of them will experience the most intense activity. Forecasting a complex dual system outbreak across a wide geographic area is not the same as forecasting a single, tightly organized storm cell. There will be variability. There will be areas that come through with moderate weather and areas that get hit hard. But the positioning of this system's active energy means that states that were outside the main risk area last week are now directly in the forecast zone for this system. The Deep South element of this outbreak deserves particular attention. Tornadoes in the Deep South behave differently from the kinds of tornadoes that dominate the visual imagery most people associate with severe weather, the wide open plains of Kansas or Oklahoma, where you can see a storm developing on the horizon from an enormous distance. The terrain across Alabama, Mississippi, Tennessee, and Georgia is varied and complex. There are hills, forests, hollows, and valleys that affect how storms track, how they intensify, and critically how much visual warning time a community has before a tornado arrives at its location. In forested or hilly terrain, a tornado can be harder to see approaching compared to the open plains. That geography is part of why the Deep South historically sees some of the most serious tornado outcomes relative to the alert levels in effect, not because the warnings are not issued, but because the terrain compresses the window between warning and impact. Communities now moving into the active risk zone for this outbreak have something valuable that the communities in the initial impact zone last week did not. Time. They have watched this develop. They have seen the reports from the West. They have had the chance to review their plans, check their shelter options, and pay attention to the forecast before the storm arrives. That awareness window is genuinely meaningful, and it is something worth using actively rather than passively. What forecasters cannot yet confirm, and this connects directly to the dual system uncertainty we have been discussing, is exactly how energized this storm will be when it reaches the Ohio Valley and the Deep South. The two low-pressure systems are still interacting. The degree to which they remain in active convergence versus beginning to separate will significantly influence the intensity and character of the activity in the eastern portions of the track. Forecasters are still tracking exactly how strong this system will be. When it reaches Indiana and Ohio, the two interacting systems could stay powerful or begin to weaken before they get there. That question is genuinely open right now, and it will be answered not in the forecasts but in the observations, the real-time data coming in from the radar and from the communities in the path as the system moves through. The forward movement of this storm is what every weather-aware person in the eastern half of the country should be actively tracking right now. It is no longer a story that belongs to Texas and Oklahoma alone. It is heading toward a much broader audience. But there is one more piece of this story that forecasters are watching very closely, and it involves something in the atmosphere above the storm that makes this week's setup more complex than the one before it. When you understand what is happening at that level, the question of why this outbreak is behaving the way it is becomes significantly clearer. Most of the conversation around severe weather events naturally gravitates toward what is happening on the ground, the wind reports, the damage assessments, the radar images showing rotation and movement. That surface-level story is real and it matters. But to understand why this second outbreak is drawing a higher level of concern than last week's event, you have to look upward into the layers of the atmosphere above the storm, because that is where the fundamental difference between these two outbreaks lives. Last week's system drew its energy from a single source. One organized low-pressure system was pulling warm, moist air upward from the Gulf of Mexico and drawing cold, dry air southward from the north, creating the air mass collision that generates the kind of severe weather the central US corridor sees every year during this period. That clash was powerful enough to produce a serious damaging outbreak. But from a meteorological standpoint, it was a relatively clean setup. One energy center, one dominant zone of conflict, a storm whose movement and behavior could be projected with meaningful accuracy because the physics of single-system outbreaks are well understood by the people who track these events for a living. What is happening right now is different at a structural level. Two separate low-pressure systems are involved in this outbreak, and they are not simply running parallel paths through the same region. They are converging, moving toward a zone of interaction over the central United States where the energy from both systems is combining, reinforcing, and creating atmospheric conditions that are more energized and less organizationally predictable than either system would produce on its own. Think of two rivers converging in the same valley at the same time, each one powerful on its own, but together creating something more turbulent and harder to predict than either one alone. That is what is happening in the atmosphere right now, and the total energy in the system is not simply the sum of the two rivers. It behaves as something more complex and less easily predicted than either river alone. That is the atmospheric picture over the central United States right now. Two energy systems are converging. The warm, moist Gulf air pushing northward is not encountering just one cold air mass. From the north, it is meeting the combined interacting influence of two separate systems, pushing from the northwest and northeast simultaneously. The zone of conflict between them is wider than a single system setup would create. The energy available to fuel developing storm cells is greater, and the question of where exactly the most intense activity will concentrate within that wider zone of conflict is harder for even the best forecast models to pin down precisely. NOAA and the Storm Prediction Center factored this dual system dynamic into their outlook from the beginning of this event's development. It is part of the reason the geographic area of elevated concern is broader than last week's. When a single, organized low-pressure system is driving an outbreak, forecasters can draw a reasonably defined zone of peak risk and communicate it with confidence. When two converging systems are driving the event, the zone of meaningful risk has to expand to account for secondary areas of intense activity that the interaction between the systems creates areas that would not exist in a cleaner single-source setup. Now let us take a moment with the hail threat, because it deserves more than a footnote in this discussion. Large hail confirmed at serious sizes in some areas already affected by this outbreak is not a supporting character in this story. It is a significant independent threat operating simultaneously with the tornado and flooding risks. Hail at the sizes being reported with this outbreak falls with enough physical force to cause meaningful property damage, to compromise vehicle safety in ways that matter when people are trying to move during a storm, and to be a direct physical hazard for anyone who is outside when it arrives. The coverage tends to focus on tornadoes because they are visually dramatic and because their wind damage is immediately evident. But hail of significant size causes real harm and real loss that deserves to be treated as a full part of the threat picture, not an afterthought. The atmospheric reason large hail is prominent in this outbreak connects directly to the dual system dynamics. When two converging pressure systems create powerful areas of upward atmospheric movement, strong vertical updrafts, those updrafts can carry ice particles high into the upper portions of the storm system repeatedly before the particles grow heavy enough to fall. Each cycle through the cold upper atmosphere adds another layer to the growing hailstone. The stronger the updraft, the more cycles an ice particle can complete before falling, and the larger the resulting hailstone. The kind of dual system convergence driving this outbreak produces exactly the powerful updraft conditions associated with large hail development in the most energized portions of the storm. What this means for communities in the path is that the threat structure of this outbreak is genuinely layered in a way that the previous week's event was not to the same degree. There is the tornado risk, which carries the most coverage and the most cultural weight. There is the flooding risk, driven by the saturated ground conditions we covered earlier, and there is the hail risk, which can precede tornado activity and arrive with speed and force that surprises people who are not watching the sky closely in the moments before it hits. Each of these three threats is serious on its own, all three operating simultaneously across a broad geographic area against a backdrop of already compromised ground conditions and reduced community resources from last week, is what justifies the elevated concern in the professional meteorological community's assessment of this event. Fox Weather and NOAA have independently characterized this atmospheric setup as more complex than the one that drove the previous outbreak. When separate organizations with different tools and different teams reach the same characterization, that shared assessment is worth noting. And when you combine all of this with where the storm is heading, the picture becomes even more serious, because the question of whether events like these are becoming more common is one that researchers and weather scientists are actively studying, and that question deserves an honest answer, which is exactly where we are headed next. When the same stretch of the country gets hit twice by separate significant tornado outbreaks within less than 2 weeks, a question starts forming in people's minds, and it forms whether you are a meteorologist watching the data or a family in the affected corridor who has now spent 2 weekends watching the sky. Is this a pattern? Is this something that is happening more frequently? Is the same region being targeted over and over because something about how these systems form and move has fundamentally changed? And if it has changed, is this what the new normal looks like? That question deserves an honest answer, not a dismissive one, and not an alarming one, an honest one, because it reflects something genuinely important that is actively being studied and debated in the meteorological and scientific community right now, and understanding the actual state of that conversation is more useful than either waving the question away or treating two events as definitive proof of a permanent shift. Here is what the record shows clearly. Back-to-back severe weather outbreaks striking the same general region within a short window are not unprecedented. Weather history across the central United States includes documented examples going back many decades of the same corridor experiencing multiple significant events within a single month or even a single week. Atmospheric conditions that produce one major outbreak often persist long enough that a second system can organize and move through before the energy pattern breaks down. That has always been part of how severe weather seasons work in this part of the country. It is not new in isolation. What has been attracting more attention in recent years, and this is where the conversation becomes more careful and more nuanced, is the question of frequency and geographic breadth. Researchers and meteorologists have been examining data over extended periods to understand whether back-to-back events like this are occurring more often, whether the traditional boundaries of severe weather risk are expanding, and whether the parts of the country east of the historical core zones are experiencing meaningful increases in significant outbreak activity. These are genuine research questions, and the fact that they are being asked seriously by serious people reflects real observations in the data. It is important to be precise about what scientists are and are not concluding. They are not saying that 2 outbreaks in 2 weeks proves that the atmospheric pattern has permanently shifted. Weather science does not work that way. Attributing changes in storm frequency or intensity to larger atmospheric trends requires long-term analysis of consistent patterns, not real-time reactions to individual events, however striking those events may be. The researchers studying these questions are, by their own professional standards, cautious about drawing lines from specific events to broad conclusions, and that caution is not evasion. It is how rigorous science works. A note here worth making clearly. The information available at this time does not support conclusions about permanent atmospheric change based on this specific outbreak sequence. Scientists are studying patterns over long time periods, and no definitive conclusions about the cause of any shift in severe weather patterns have been established at this point. Anyone claiming certainty about why back-to-back outbreaks are occurring from any particular scientific or policy direction is working beyond what the current data confirms. What the data does support, based on research that has been building over recent years, is this. Researchers have noted that certain atmospheric setups in recent years have produced severe weather across a wider geographic area than older historical patterns would have suggested for the same time of year. That is a measured observation. It does not tell us what next spring will look like. It does not mean every year will feature this kind of sequence. It means that some researchers have found that the conditions needed for these events may be showing up across a wider area than they used to. For the communities that have now been dealing with 2 significant outbreaks in 10 days, this is not an abstract research discussion. It is deeply personal. If you have lived somewhere for 30 or 40 years and understood roughly what severe weather season means for your area, and you're now in the middle of something that feels like it is exceeding that understanding, you're not wrong to feel that. And you're not wrong to ask whether the mental map you built over decades of living there needs to be updated. What forecasters and researchers would say in response to that is not, "Yes, everything has changed," and not, "No, this is all normal, relax." What they would say is, the tools forecasters use to track and communicate these storms have improved significantly in recent years. And the most effective thing any individual or community can do in the face of a more complex severe weather environment is exactly what the most prepared communities always do: stay connected to trustworthy, accurate information sources and treat forecast windows as action windows rather than waiting windows. The conversation about frequency and pattern will continue in research institutions and weather organizations long after this specific outbreak moves through and becomes part of the historical record. It is a conversation worth following as it develops. But for right now, for the next day or two, what matters most is not the long-term question. It is the immediate one. What does the forecast show for the states in this system's eastward path? What are the Storm Prediction Center and NOAA watching most closely? And what does a calm, clear, practical picture of the next 48 hours actually look like? That is exactly where we're going next. Let us come back to what matters most right now, the forecast for the communities still in this storm's path. What does the next day or two actually look like? What is confirmed in the forecast? What is being actively watched? And what does calm, practical awareness look like for the communities this system is moving toward? The Ohio Valley is the next major focus of concern as this system tracks east. Portions of Indiana, Ohio, Kentucky, and West Virginia sit directly in the path of this storm's projected eastward and southeastward movement. Forecasters at NOAA and the Storm Prediction Center are watching the timing of this system's arrival in the Ohio Valley closely, because the ongoing interaction between the 2 low-pressure systems driving this outbreak will continue to influence how intense the activity is when it reaches that region. Whether the systems are still in active convergence when they reach Indiana and Ohio, or whether they have begun to pull apart and lose some of their combined energy, will significantly shape what communities they experience. That question is not yet answered in the current forecast. The Deep South Mississippi, Alabama, Tennessee, and portions of Georgia represents the other primary zone of active concern as the system simultaneously tracks south and east. This is the part of the storm's projected track where all of the factors we have discussed converge in the most visible way. The terrain complexity that reduces visual warning time, the Gulf moisture that continues to feed the storm's energy as it pushes into lower latitudes, the saturated ground conditions across the portions of this region that also received significant rainfall last week. All of these factors are present in the deep south portion of the track, and the Storm Prediction Center is treating the forecast period covering these areas with the same elevated seriousness it has applied to the storm's earlier stages. What the current NOAA outlook confirms is that the conditions supporting tornado development, large hail production, and damaging wind activity remain active across the eastern portion of this system's track through the relevant forecast window. That confirmation is not a prediction that every community in the risk area will experience significant weather. If you are in the eastern half of the country right now, particularly if you are in the Ohio Valley, across the Deep South, or anywhere in the projected path of this system, this is directly relevant to where you live. Not because the goal is to create anxiety, but because being direct about what the forecast shows is the most genuinely useful thing I can do. The storm is still moving. The active risk window is not behind us yet for the communities in the projected eastern path. What practical awareness looks like right now is this. Know where your confirmed severe weather alerts are coming from. The National Weather Service and your local NWS office are the authoritative sources for what is happening at the county level, not social media, not second-hand reports, not rumours. Those official sources exist specifically to give communities the most accurate, most timely, most precise information about what is approaching. Use them. Second, have a clear, specific plan for what you do if a tornado warning is issued for your exact location, not a neighborhood plan, a specific address plan. Know where your shelter is and how long it takes to reach it from wherever you are likely to be when a warning comes. Third, if you know people in the projected path who may not be paying close attention to the forecast, reach out now, before the active window arrives. Information shared between people who care about each other is one of the most effective forms of community resilience there is. The tone that experienced forecasters hold during events like this is one of measured watchfulness, not fear, not dismissal. There is a real difference between those two orientations, and the difference matters enormously when it comes to how people respond. Fear produces paralysis or overcorrection. Awareness produces action. The communities that historically fare best in severe weather events are the ones that translate accurate, grounded information into calm, specific preparation, and that is exactly what the coming hours call for across the eastern portions of this storm's track. On the other side of this window, the forecast modelling suggests that as the two low-pressure systems begin to lose their convergence, as they inevitably will, because all storm systems weaken and separate over time, the active severe weather risk across most of the affected corridor will begin to diminish. That is the expected trajectory of this event. It does not eliminate the risk in the short term for communities still in the path. But it does mean that this sequence has an endpoint, and that the communities in the initial western impact zone are moving toward a genuine recovery window as the storm tracks east. The same recovery window will eventually reach the eastern portions of the track as well. For everyone who has been living in this for the past week and a half, who went through last week's outbreak, and is now watching a second system approach before the first one's aftermath is resolved, the knowledge that this specific sequence has an endpoint is worth holding on to. The storm is moving. It will eventually move past the most populated portions of its projected path and begin to weaken. Until that point, staying aware and staying connected to accurate information is the most powerful thing you can do. And that brings us to the part of this story that does not show up on radar, the part about the people in the path, and what 2 outbreaks in less than 2 weeks, hitting some of the same communities twice, says about something that's steady and worth acknowledging. After all the data, after the atmospheric analysis and the dual system dynamics, and the saturated ground conditions and the forecast windows and the geographic tracking, what this story is ultimately about is people. Communities that are navigating something genuinely difficult. Families who spent last week in the middle of an outbreak and are now watching the forecast with the particular kind of attention that comes not from curiosity but from experience. People who know what a darkening sky means because they have watched one recently. That is not an abstract news event. That is a real lived experience unfolding right now across a wide stretch of the country, and it deserves to be acknowledged as such. There is something in the way communities respond under repeated pressure that rarely gets the attention it deserves. Not the dramatic moments those get covered, but the quieter, steadier expression of it. The neighbour who calls to check on the person 2 streets over. The family that has already gone through last week's aftermath and is already making a plan for this week too. The person who was not going to watch the forecast but reached out to someone who told them to pay attention. That kind of preparation is not passive. It is an active choice to care about what happens next to yourself and to the people around you, and it is happening right now in every community this storm is moving toward. What this second outbreak also tells us, and I think this is worth sitting with honestly, is that staying informed in real time is not something you can do intermittently and trust that you have a complete picture. The gap between this is a weather event in another part of the country and this is directly relevant to where I live can close in a matter of hours when a system is moving the way this one is moving. The people who have been following this situation from the beginning of the week, who watched the first outbreak, followed its aftermath, and then paid attention when the second system began to organise, have had more time to process what is happening and prepare for what is coming than the people who are just now tuning in. That is not an accusation. It is just the reality of how fast-moving weather events work, and it underlines why following trusted, grounded, accurate sources consistently, not just in the moment a storm arrives, but in the days before, it is genuinely valuable and not just a good intention. Channels like this one exist because that need is real. The goal is clear: honest information delivered with the same calm and honesty that a trusted friend would bring to a serious conversation. That is the standard I try to hold, and it is the standard the communities dealing with this deserve. This storm is still moving. The story is not finished. As this system continues to track east over the coming days, We will be here following it, updating what we know and giving you the clearest possible picture of how it is developing and what it means for the region still ahead of it. If there are meaningful updates to the forecast, to the alert posture, or to the storm's behaviour as the two systems continue to interact and eventually separate, you will hear about it here, in the same measured, grounded way we have walked through everything today. If this video helped you understand what is actually happening and why this second outbreak is drawing the serious attention, it is share it with someone who needs to know. Not to spread concern, but because passing accurate information to people you care about is one of the most concrete acts of genuine community there is. Send it to someone in the Ohio Valley, pass it to a family member in the Deep South, forward it to anyone you know in the path of this system who might not have the full picture yet. Good information, shared between people who trust each other, is one of the things that makes communities more resilient not just in the moment of a storm, but in everything that follows. Drop a comment telling me where you're watching from, or if you have someone you love in the path of this storm. That community of people paying attention together is what this is about. I read every comment, and in a situation like this one, that connection matters. The storm is still moving, and we will stay with it.